All right, so let's talk about what a trivial solution is. Remember, the trivial solution is when I'm looking at ax equaling 0. The trivial solution is when all of the entries of the vector x are 0. So when does it have the trivial solution? When I'm looking at a homogeneous system. Homogeneous system means that it's equal to 0. All right, so we're going to use that a lot when we're trying to establish whether a set of vectors are independent or dependent. So if I have a set of vectors, they are called linearly independent if I try to put numbers in front of each of these vectors equaling 0, and if the only solution is the trivial solution, that means each of the xi's are 0. Each one of those x's have to be 0 in order for this linear combination to get to the 0 vector. It's called dependent if not all of the weights are 0. So if I could have one of them to be 2 and one of them to be 4, and if I could get to the 0 vector, there's a relationship, so we say they're dependent. So remember, if there is a non-trivial solution if there is a free variable. And that's what we're looking at to see if it has a trivial or a non-trivial solution. All right, so how do we check? We solve the homogeneous system. So if I'm looking to see if these three vectors are independent, I'm going to put them together in an augmented matrix, and I'm going to see if there is only the trivial solution to see if they are independent. So if I put them in this augmented matrix with the 0, right? And then this, if I can just switch the rows, right? And I can see that I'm going to get no free variables, right? Because it's x1, x2, x3. I'm going to have negative 3, x3 equaling 0. So that'll give me x3 equals 0 and back up the line. So there's only the trivial solution, so that means this set of vectors are linearly independent. So in general, that's what you want to do to find out if they're dependent or independent, solving the homogeneous system. So what if it's just a set of a couple of vectors? If I'm looking at just two vectors, I want to check to see if one is a multiple of the other. If they are, it's dependent. If I'm looking at a set of vectors and the 0 vector is one of them, so if the 0 vector, meaning like all entries are 0, then for sure they're dependent. If I'm looking at a set of vectors and there are more vectors than entries, then I can establish that the set is linearly dependent. So say if I have 3 vectors in R2. So I'm looking at this set of vectors right here. Are they independent or dependent? Well, here I have 3 vectors in R2, just like I just said up here, so therefore they're dependent. All right, so looking at these 2 vectors, there's not more vectors than entries. Neither one of them is the 0 vector, and they're not multiples of each other, so I can say for sure that they are independent. So if there's just a couple of vectors, we can use this process of elimination to find out whether they're dependent or independent. Looking at these 2 vectors, neither one is the 0 vector. There's only 2 vectors and they're in R3, but I notice they are multiples of each other. So if they're multiples of each other, what that means is I can have an x1 times this vector plus an x2 times this vector, and that will get me to the 0 vector. So there's a solution other than x1 and x2 equaling 0. I can see if I let x1 equal 1 and x2 equal 1 that this will work. So that means that they're dependent. There's a relationship between them. All right. So if I'm looking at a set of vectors and 2 or more of them are dependent, the set of vectors of 2 or more vectors, they're called linearly dependent if at least one of the vectors is a linear combination of the others. So that might lead you to think, oh, I know, I'll just check to see if each of the pairs are related to each other. So if I'm looking at the vector u and v, neither is a zero vector, they're not multiples of each other, so this set of 2 is independent. If I'm looking at the set of u and w, this set is independent because they're not multiples of each other and they're not the zero vector. All of these individual sets of 2 are linearly independent because they're not multiples and there's not the zero vector. So each set of 2 are linearly independent. Does that mean that this whole set is linearly independent? No, it does not. So determine, is this set of 4 vectors independent? It is not, because I have more vectors than entries. I have 4 vectors in R3, right? I have 4 vectors in R3, so that means they're dependent.